Okay. Okay. Thank you for confirming. Okay. So this structural coffee corner is a new name that we are given for our special interest group. In the previous months, you might have heard about SIG meetings. SIG stands for Special Interest Group, Structural Special Interest Group. From June month, this month onwards, we changed the name to Structural Coffee Corner. And these sessions will happen on every third Thursday of every month. This is specifically curtailed for Southeast Asia Pacific region. And the topic for today is complete workflow for liquid retaining structures. This is not just only a complete workflow, but also totally a new workflow for liquid retaining structures. So many of you are already used to this platform. You can see many icons at the bottom of your screen. For those who view this webinar on demand after the live session is over, you can utilize the media player and slides to switch between these two. And this webcast is streamed through your computer, so there is no dial-in number for attendees. Please make sure your computer speakers or headphones are turned on and volume is set to an audible level so that you can hear me clearly. Webinars are bandwidth intensive, so closing any unnecessary browser tabs will help conserve your bandwidth and prevent issues. A hardwired internet connection is recommended than a wireless connection. If you're not seeing your slides advanced or if there is any hanging issue, we would suggest you to refresh the web page by pressing F5 key on your keyboard. Okay. And after the end of the sessions, you can log into our Bentley LAN server using the same credential that you used to register for your webinar today. And then you can print the certificates from there. If you're not created your profile, you can use this lms.bentley.com as shown in the bottom left side corner of the slide to create a profile for yourself and use the same credential to register for the webinar so that you can print the certificates for the webinars that you're attending. So before I start the presentation today, I would like to have two polls. I would like your participation on this to understand the type of audience attending here today. Do you do liquid retaining structure analysis and design? Okay, like water tanks for drinking water or wastewater treatment plant. Okay. So I'll give you 10 seconds to answer this. So please participate in this poll. If you or your company do liquid retaining structure analysis, please say yes. If not, no. I'll give you 5 more seconds for this. Okay, thank you for participating in this poll. Let's see the result. 86.5% of you have mentioned that yes, you do this liquid retaining structures, and that's why you are here attending today this session. Okay, thank you. The next poll. What are the pain points in the software that you use for liquid retaining structural analysis? Please help in participating in this poll. My discussion with many of our StatPro users in the past used to tell me that number one feature is design not available for walls for liquid retaining structures. You need to design the slab and wall, isn't it? So for walls, StatPro does not have a good design feature. That was the main pain point. Because of that, many of you have developed spreadsheets in the past. And also, some of you tell that the loading application for the liquid, which is retained by the tank, application of loading is time consuming. So that's what I hear as pain point in the past. That's why I put in here. So please let me know if that is what your pain point is also. Okay, so I give you 10 more seconds for answering this poll. Okay, thank you for participating in this poll. Let's see the results. As I expected, most of you mentioned that no design and detailing feature, that are the pain points, and modeling is not easy. That is another pain point, as I expected. Only few of you mentioned other difficulties, but majority of you mentioned as I expected. Okay, thank you. Okay, so with that, I'll share my screen. We'll go for a live demo. The live demo will be a combination of a PowerPoint presentation as well as slides. Okay, myself as Madan Elimalai. Some of you may know me already. I'm based out of Singapore office, and my job as a technical manager, I take care of the user advancement team in Southeast Asia Pacific region for structural, offshore structural, and piping. Okay, the agenda, short agenda for today. Today is not a big topic, it's just a small topic focusing on only the liquid retaining structures. And basically, totally a new workflow in the current versions of StatPro. So it won't take more than 30 minutes for completing this presentation. So we'll first look at the workflow for liquid retaining structures. Slightly new workflow for old users of StatPro. And then we'll see some notes on licensing. What is the license you need to utilize this complete workflow for liquid retaining structures? And we'll look at an example for modeling, analysis, post-processing, design, detailing, estimation. Okay. Then finally, we'll summarize and open up for a question and answer session. Okay, so here's the workflow for liquid retaining structures in the current version of StatPro, the current release, which is StatPro Connect Edition version 22, update 6. To be exact, the version number is 22.06.00.138. If you use any previous version of StatPro, you may not have the first workflow, that is modeling using the structure wizard in StatPro Physical Modeler. That's what I mean by SPPM, StatPro Physical Modeler. Only in the latest version of StatPro Update 6, version 22 Update 6 of StatPro Connect Edition, we have this new structure wizard in the physical modeler, StatPro Physical Modeler. That speeds up the modeling time, not just the geometrical modeling, but also the load application. You just need to fill up the tank with the water. Just mention the height of the water and the density of the water. That's it. Okay, the program will calculate the loads automatically. That is a major step in the current version. Analysis and post-processing in the analytical modeler is nothing new. That is same like the old version. And design and detailing in STAD Advanced Concrete Designer, STAD workflow, otherwise called as RCDC. Okay, the new name is STAD Advanced Concrete Designer. The old name is RCDC. This is a new feature for liquid retaining structures, starting from. This is again new in update 6 only. In update 5, it was released as a technology preview. In update 6, it was released officially. Okay. And while speaking on this slide, the next release of StatPro Connect Edition version 22, update 7, is planned to be released by next month. And that release will have the Singapore National Annex and Malaysia National Annex for liquid retaining structures also. I have a beta version already. So today I'll be showing you a preview of the update 7, which has the Singapore National Annex and Malaysia National Annex for its liquid retaining structures. That is Eurocode 2, part 3. Okay. So this is the basic simple workflow. On all you need is just StatPro latest version. Okay. And notes on licensing. In order to utilize the new structure wizard in the physical modeler, which is basically a tank wizard. The structure wizard, we have only a tank wizard in the physical modeler. That requires you to be under select. So make sure the structural select entitlements is selected. This you can configure in your StatPro license configuration. That means users of StatPro who are under active select contract with Bentley. Select or ELS or E365 or Virtuoso, any active contract with Bentley under maintenance. Okay. Then this feature is given free of cost. Okay. That is what structural select entitlement means. Some features, basically the three features that is given free of cost. One is this structure wizard in the physical modeler to model the tank very easily. Another feature is steel auto drafter, which some of you might have heard of it already. Another one is building planner. So these three features, you can use it free of cost as long as you are having maintenance contract like select contract with Bentley. Okay. And next, in order to utilize the tank design and detailing feature in Rcdt or Advanced Concrete Designer, you need to have the StatPro Advanced license. Okay. So basically, these two are the requirements, licensing requirements, in order to complete the workflow for liquid retaining structure and modeling, analysis, design, and detailing. Okay, hope that is clear. So let's see example of modeling the tank. Compared to the older versions of StatPro, significant improvement in the latest version of StatPro by the introduction of this tank wizard or the physical modeler structure wizard. So here you can see the first screen of StatPro, advanced license. Okay, I choose metric units, specify a file name, choose your location of your folder, use the physical modeler. Okay. Make sure the license is configured to use StatPro Advanced and structural select entitlements is selected. Hit the create button, and now we are with the physical modeler of StatPro. This physical modeler has undergone significant investments, significant development is going on here. Day by day, this is improving. But here you can see the structure wizard in the physical modeler. All you need to do is just fill up the blanks, a number of compartments and base slab thickness, total length, total width, toe to edge of walls, height of walls, outer wall thickness, separator wall thickness, whether you have columns and beams. You just need to put a tick mark if you want to have a columns and beams to support the roof slab. For my example, I'm not going to use that. Material, you can see it is empty, which we can assign it later. And include roof slab. If you want to have a roof slab on the tank, you can select that. And note that simply supported slab is just a tick mark that will automatically release the edges of the slab or the roof slab. So for my example, I'm not going to consider a roof slab. So that finishes geometry modeling. Next is the supports. Here you can see the slab can rest on ground that is supported by soils or piles. If you have piles supporting the slab, then you need to specify the number of piles and specify the stiffness of the piles. Or if you don't want to be supported by piles but directly sitting on soil, then specify the soil modulus, separate modulus. I used 80,000 kilonewton per meter square per meter. Okay, soil modulus. This is coming out of soil testing report, or you can refer to a book like Bowell's book on foundation engineering. By default, these soil springs are generated automatically using the subgrade modulus, and they are treated as compression-only springs. Okay, next is loading. You can either use the load group, or a load group means reference loads. Notice that in the past I have done a separate webinar on load groups. And the registration link which you have clicked already has a link to this webinar also, on-demand webinar. And here I am specifying the fluid density and the fluid height on both the compartments. Now I rendered the water tank. You can see here it is showing as outline view. And it doesn't show a complete rendered view because we didn't assign the material yet. So now from this template, the structure wizard template, I'm transferring the model to the main user interface of the physical modeler. I can see a preview of the tank. If all is okay, I can press OK. You can see the water is filled up in the tank. You can see in light blue color, greenish blue color. Now I'm assigning a material from the catalog. Okay, concrete material. And you can now view the complete rendered view. Okay. So simple fill in the blanks. You can quickly model any number of compartments. Another button click, you can see the meshing, the finite element mesh and stitching all happen automatically. Anytime you can use the options button in the file menu to modify the mesh size. By default is 1 meter. Okay, I tried with 0.25, it is too fine. I tried with 0.5. 0.5 seems to be reasonable for me for demo purposes. Yeah. So I change the mesh size to 0.5 and you can see the loads are also created. Dead load and the compartment load filled with water, compartment 1 and 2. And you can see the lateral pressure as well as the vertical pressure of water is automatically calculated. And here I just modify the loads. For example, the first load is an empty load case, so I delete it. And the second load is actually dead load, which has a self weight of y minus 1. So I leave it as it is. This is all created by the wizard automatically. And then the compartment load. So instead of compartment and compartment bracket 1, I change it to compartment 1 and 2. Okay. And the category you can see at the right side is fluids. For second and third load cases, fluids. Okay, so these are the basic 3 load cases we have for this model. I do a small integrity check on the modeling to validate the modeling. And at the bottom output screen, you can see there is no warnings or errors in the modeling. Very useful tool if you're particularly new with the StatPro physical modeling. And then I click on the analytical modeling. Now the program is writing an input file for StatPro, and we go back to the analytical modeler interface of StatPro, which many of you are familiar. Same like old StatPro V8 interface. Okay, now you can see the loads automatically created from the physical modeler. So you just notice the amount of time you spent in modeling this tank and loading and boundary condition is within a few minutes we are completed. Now we are doing automatic load combinations. So you can see this, the automatic load combinations is introduced in the physical modeler already, but we still don't have the Eurocode load combination generator yet. So for this reason, I'm not going to use the physical modeler automatic load combination generator, but I'm going to use the macro, which is available in the analytical modeler. Anytime you can switch between the analytical modeling and physical modeling using the left side workflow options. Okay. So now that we have finished the modeling, let's move on to the next step, analysis and post-processing. Okay, so now we have these 3 load cases. Now all we need to do is generating the combinations, but let's verify the first, the 3 load cases, okay? Let's view the loads. You can see the compartment loads and the water loads in both the compartments. And see the springs generated in the mat, in the slab. It's all done automatically in one wizard. Now I go to the user tools and use the Eurocode load combination generator. Okay, and here's the macro, and I use the repeat load combination, not a normal load combination, but I use the repeat load option, and I use the category E for storage areas, and change the category for fluids to variable. Okay, sometimes the tanks can be empty, sometimes it can be full. That's why I set it as variable and hit the generate button. 16 load combinations I have generated using the Eurocode load combination generator. You can see on the right side, the load combinations per Eurocode I have generated automatically. But note that since these load combinations are generated in the analytical modeler, when I go back to the physical modeler, these load combinations will get erased. To avoid that, I use these utilities drop physical model command. This will break the link between the physical and analytical modeler. From this point onwards, I will be able to use only the analytical modeler and I will not be able to go back to the physical modeler. So I would suggest to create a backup copy of the file before you do this step. And now I run the analysis. And you can notice that since the springs are compression-only springs for the base slab, the StatPro will do an iterative analysis. And you can see the program reports that tension compression converged by iteration 1 for load case so and so, so and so. So make sure their load cases are all converged. And I check the post-processing results deflection 2.18 millimeter. That is reasonable. And view the output file. Make sure there are no errors, no warning messages. And note this notes which says that the tension compression is converged for all the load cases. This will be sometimes problematic when you apply wind loads, but most of the times, if you use the load combinations correctly, using repeat load or reference load, then you won't end up problems with non-convergence of tension compression analysis. Okay, remember to use the repeat load or reference load. Do not use the load combinations. Okay, because it is a sort of non-linear problem because the springs are active only for compression forces and they will be inactive for tension forces. Hence, the stiffness matrix will change according to the load. Okay, so that's why you need to combine the loads using realistic combinations like repeat load and reference load, and not use the load combination feature. Okay, don't use the load combination. So now we look at the other post-processing results, such as a local axis bending moment contour, mx, my, and we can change the load cases. I would be more interested in load case 1003. That is a combination that covers both the loads, water loads in both the compartments. And we can also plot global moment stress contour. You can see the global moment for the slab. This is particularly useful when you have triangular mesh and irregular meshes. Okay, and the local axis moment will be confusing to interpret during those times. So this global moment stress contour will be very handy. Now we are looking at the walls in both the directions. Okay, global moment contour. So in the past, users used to use this result and they use manual calculations or using spreadsheet to do the design. But now we can use the new feature in Rcdt using the StatPro advanced license. So we have now finished the modeling, analysis, and post-processing. Next thing is design, detailing, and estimation. So on the left side, I have put in the current version dialog box where users need to use the design code EN0211-2004 plus EN02-3. That is the code for liquid returning structure, -2006 UK. So this is the code that you need to use in the current version of StatPro. Whereas next month, when we release the update 7 of StatPro Connect Edition version 22, you need to use the right side dialog. The dialog will be changing as shown in the right side picture. You can use all the highlighted codes, the generic Euro code EN0211, or you can use the Singapore and Malaysia National X codes, as well as UK National X code EN0211. We also have the Belgium code, Belgium National X also implemented. And we also have the Philippines NSCP 2015 code now. And by next month, we'll have the Australian AS 3600 2018 code as well. And all these codes can able to design pile cap, footing, column, wall, beam, slab, and only the highlighted code, this European codes with national access, can able to design the water tank structure. Okay. And this is the screen capture from the Singapore National X NA to SSEN 1992-3, 2010, confirmed 2015. Singapore National X says that the nationally determined parameters for these classes, Singapore decision says that use the recommended values as specified by the Eurocode. Okay, so there is no special requirements as per Singapore National X. Okay, so with that considering in mind, let's see how we are designing this water tank. Use the advanced concrete design feature, the workflow button on the left side. that will launch this StatPro Rcdt. And here I'm choosing the EN02, Euro Code 2, Singapore National X. Notice that this version will be released only next month. I'm showing you the beta version today. Okay, so at the bottom you can see the new Philippines and Australian codes. And on the top you can see the ACI and Euro codes and British code and Indian codes. So for this example today, I'm going to use the Euro code with Singapore National X, and I'm choosing the water tank structure. Notice that Rcdt is capable of reading not just from StatPro, but also ETABS and RAM structural system file. But for water tank structure, it would read only the StatPro file. It will not read ETABS and RAM structural system file. Okay. For other elements like pile cap, footing, column, wall, beam, and slab, you can use the model from any of these three softwares as shown here. Okay, I'm changing here the section cut settings from 0.5 to 0.75 because this value should be more than the mesh size that we used in the StatPro model. Remember, the mesh size I used in StatPro was 0.5 meter. So here I need to change the default value of 0.5 to 0.75, slightly more than the mesh size that we used, so that the results will be more accurate. Okay, so now we are into the water tank structure form in Rcdt. And the settings menu, I'm specifying the concrete grade, steel grade, the rebar diameter, and detailing options, either to use a fixed diameter or fixed spacing. And similarly, for slab, we have a separate design parameters dialog, which is similar. The preferred rebar, I prefer to use a fixed rebar and let the program decide on the spacing. Some users prefer to fix the spacing and let the program decide on the rebar size. So both options are available in the program. It's up to the user to choose which method they want. So I'm fixing the rebar size as 16 mm, rebar diameter as 16 mm. Okay, and next is the crack width settings. So here I'm specifying the crack width check, drying shrinkage, thermal shrinkage. These are all specified in the EN0203 code, code for liquid retaining structure. Okay. So we implemented almost all the clauses in the code. Okay, so we finished setting up the settings, and now we choose the load cases for which you are designing the tank. Okay, and notice that the fluid category is not available in Rcdt, so we use that as others. Okay, so after we select the primary load cases, we can click on Add from Analysis. So the load combinations can be imported directly from StatPro. Remember, in StatPro, we use the macro to create the load combinations as per Eurocode. So those load combinations that we used in StatPro, we have just imported it here. And for crack width, again, I imported the load combinations from StatPro and select one of the unfactored load combinations for crack width check. Okay, so we did the load combinations. We imported the load combinations for both design and crack width. Okay, now we are ready for our wall design and slab design, but we need to do it one by one. Okay, so first we'll design the wall design. Okay, and this spreadsheet shows the wall numbers, the surface numbers, the length, height, and thickness of the walls, each walls, the concrete, steel grade, the cover. Okay, and each wall you can highlight and verify the wall number. And again, we can have set up some design and detailing settings here, which we already did it. We can also have control on the curtailment of the reinforcement and the number of zones, both vertical and horizontal, which I all leave it to default. So now I hit the auto design option, and at the bottom left side corner, you can see the progress. Now we are designing only the walls, not the slabs. Okay, so now the design is complete. You can see the green color on the spreadsheet, left of the spreadsheet, meaning that all the walls are passing. And here you can see the wall number and the reinforcement here and the zones here. If you want to provide uniform reinforcement, you can copy and paste the reinforcements on different rows. And if it is acceptable, the program will accept it. If it is not acceptable, the program will give you a warning. Okay. Even after design, you can click on right mouse button on any wall, and you can see this redesign option where you can modify the thickness, you can modify the reinforcement diameter, spacing, everything, and perform a redesign. Okay, and then you can use this reporting option to pull out wall schedules. So the wall schedule looks like this: tabulated set schedule, showing you the zone numbers for each wall thickness, and the reinforcement. We can also pull out detailed drawings. For sample, I pull it out only for one wall, plan view, section view, and if required, the standard details such as cutout, plan junction, vertical junction, show plain cement concrete, zone reference for vertical and horizontal walls or horizontal zones also. And now you can see the detailing. The color code of the surface legend is shown here, and the vertical reinforcement zoning layout also shown here. And here's the elevation view, so showing the zones. These are horizontal zones, and this is the reinforcement diagram, cross section of the wall. So you can see T16. T stands for tall steel, but in Singapore we use H instead of T. In India we use T. Here we use H. Well, it's very easy to modify that. Later I'll show you how to modify that. And these are the standard cutout details and junction details. Okay. Next, you can see the other type of reports that we can pull out. Yeah, the rebar bark manager. So here, as I mentioned, you can change the T rebar annotation from T to H. Each country follows a different convention, so program is fully customizable. And utilize this option to show how to change the diagram, the annotation of the reinforcement from T to H. Now you can see it's showing H. And these drawings can be saved as a DXF file or opened directly in MicroStation. And this is the design summary, giving you the design summary of the wall that you have selected. This summarizes the reinforcement area of steel required and the reinforcement that is provided and the flexural crack width. Okay, and the governing bending moment. And thermal shrinkage calculation, drying and thermal shrinkage also. Next is the design calculation. This gives you step-by-step calculations. Detailed calculations showing you the clauses of the code and the formulas. So you can see the Singapore National X shown in the report. And the detailed step-by-step calculations for each face of the wall. Phase 1 means maybe inner side, phase 2 maybe outer side of the wall. So each wall has two phases. So both the phase reinforcement calculations is shown up here. Shear check, crack width check. All detailed reports are shown up here. There are separate report for drying shrinkage and thermal shrinkage. And separate report for crack width check also. Stress limit check as well as crack width check. Failure diagnostics will help you to find the reason if any wall is failing. In our case, there's no wall that is failing. Next is bill of quantities. You can choose Singapore dollar or any other currency that you follow in your country and use the local rates and use the three options on the top: BOQ summary, reinforcement type wise, rebar wise. to pull out this quantity and cost estimation. That's it. Within a few minutes, you noticed how many reports we have pulled out. Including the detailed drawing and text schedule. Notice that we finished the design only for the walls, and not yet for the slabs. If you want to have a detailed drawing for the complete tank, just select all the walls. That's it. You can see within few seconds, the complete detailing is ready. Previously, we just generated the detailed drawing only for one wall. Now let's go to the tank slabs. Okay. So proceed with the tank wall, the slab design. The slab thickness that we used assumed for analysis is 600 millimeter. So now we perform the design. The program gives you the reinforcement and spacing. 16 mm dia to 175 mm center to center. Bottom reinforcement. Top reinforcement is same diameter, but 170. Same spacing also. But you can, using the redesign option, you can try to optimize the thickness here. See here, I'm trying to change from 600 mm to 300 mm, but the program reports failure. I try now 400 mm. Again, it says fail in shear design. Now I change to 500 mm. Now 500 mm is sufficient. The program is able to give the reinforcement and doesn't give any warning. So we can accept the change. So now using this redesign feature, we optimize the thickness of the slab from 600 mm to 500 mm. But we need to go back into StatPro to perform one more time analysis. That we'll do it later. Okay, let's see the other features in this program. You can pull out this section forces table, and you can choose whether shear forces or axial forces or bending moment. Okay, for the slab. Okay, so now let's pull out some reports. Obviously, number one is the general arrangement plan. So here we got the plan, and here we got the top and bottom reinforcement. And we can also pull out a slab section drawing along with standard cutout details. There you can see the section drawing in both the direction. And again, design summary, design calculations, crack width check, dry shrinkage, and thermal check, and bill of quantities are all similar like the wall design feature which we shown before. Okay. So within few minutes, we have finished the wall design as well as slab design, also detailing, also bill of materials, and also cost estimation. So to summarize our presentation today, modeling the rectangular water tanks along with the loads and supports have become easy with the new structure wizard in the physical modeler from StatPro Connect Edition version 22 update 6 onwards. Modeling has become easy for rectangular water tanks. Design, detailing, and cost estimation for the rectangular concrete water tanks by Eurocode has also become easy with the StatPro Advanced license in the latest version. So that those are the major two features in the recent versions of StatPro that makes life easier for the structural engineer who do the rectangular water tank above ground or below ground or elevated. Notice that the wizard helps you to get the important portion of your water tank. And if you are supporting that water tank by ground or by columns, then you need to do the extra modeling. And if you want to apply wind load, that you can apply separately the wind loads. Okay, but the wizard will just help you to complete the major portion of the modeling. Okay, that's it. If it is underground, then there'll be some additional lateral restraints that we need to model extra in StatPro. But we can extract the major portion from the structure wizard and then proceed with the other minor modeling in the physical modeler itself. Okay, so that is the summary of today's presentation. Major two feature, modeling using the structure wizard in the physical modeler, and then design and detailing using the Rcdt. Currently, only the Eurocode is implemented with Singapore National X and Malaysian National X and UK National X. And in future, we'll be implementing more and more codes as per your request. Okay. And Slab Pro Advanced license is required to perform the design and detailing. And the structural select entitlements is required to utilize the structure wizard in the physical modeler to model this tank easily. Okay. So if you're not subscribed to our Bentley Structural YouTube channel, please subscribe to it. You can see hundreds of videos available there, mainly demonstrating the latest features of our program. Land Server, if you're not using it already, this is a free feature for our users who are under active select contract with Bentley, ELS or E365 contract or Virtuoso contract. Learn.bentley.com you can utilize to attend trainings, both live trainings as well as on-demand trainings are available for almost all the programs of Bentley. Please utilize this training features, and then you can also print the certificates directly from this site. To get support from Bentley, you can utilize the forums, blogs, wikis in our communities.bentley.com, or you can raise a service request by for one-to-one support. Connect Advisor opens up automatically whenever you open any Bentley program and advises you on the discussions happening in our community site and the YouTube videos and also the Land Server videos on the program that you open. So before we move on to the question answer session, we have some two more polls. So I need your help in answering that. So now that you have learned the complete workflow for liquid retaining structures, do you plan to use this feature in your future projects? So please help me in participating in this poll. Give you 10 more seconds for this. Since this is a completely new workflow that our development team has invested the resources to implement this feature, we want to know how useful it is for you. So please help me in answering this so that I can bring back to the development team and say you should develop more such features. It's really useful for users. Okay, so thank you for participating in this poll. As I expected, 95% of you mentioned yes, you will be using this feature in your future projects. Thank you for that. Our development team will be happy for the hard work they have done. Next feature, next poll. Would you like this feature to be implemented to the following design codes also? Right now, the feature is available only for Eurocode, Singapore National X, Malaysian National X, and UK National X. Would you be interested in implementing this feature as the ACI code, Australian code, or other codes? So please help me in answering this. So this attendees, the invites have been sent to all throughout Southeast Asia as well as Australia, New Zealand region. The attendees may be from other parts of the world also, which you may be interested in other codes. So that's the reason why I implement this poll. So that the results I can pass it on to the development team to support the implementation of the other codes. Give you 5 more seconds for this, answering this poll. Thank you. Okay. Thank you for participating in this poll. Following the presentation for today, would any of you like to be contacted by our sales team? Please answer this poll. Okay, I'll leave you 5 more seconds for this, and now we can go back to our Q&A session. Okay, so please use the Q&A tab in the bottom to put in your questions. I can read one by one and answer it. Which code can be used for design steel Loose tank. Okay, this webinar is mainly for concrete tanks, and for steel tanks, StatPro has steel design codes. You can use any code that you wish, Euro code or American code, to design the steel members. And StatPro is already good in designing the steel. It's just that the concrete walls and slabs which were lacking in StatPro, which we filled up in the latest version. For steel tanks, it's already good, but still we do not have the steel plate code check. Okay, steel plate code check, we need to use the spreadsheet to design. But for steel members, we can easily do that in StatPro. Okay, sorry, I'm reading from top to bottom. Okay, sorry for that. We'd like to know, in particular, the loading regime of gravity filter media. Gravity filter media. Loading regime of gravity filter media. I'm sorry, I'm not familiar with this question, gravity filter media. Whatever it may be, if it is a filter that is used in a treatment water tank, all you need to know is the loading, whether it's a point load or a line load or a area load. You just need to find out the load, and you can apply the load using the various loading tools. Note that you're not limited to only the wizard, the options available in the wizard. Wizard will help you to get most of your modeling done. That doesn't mean that 100% of the modeling and loading you have to do it only with the wizard. After you bring the model to the main graphical user interface of physical modeler, you can use any tools to model any loads. It could be wind load, could be seismic load, and maybe like this filter media load, what you mentioned, that can be also modeled as point load or member load or plate load using the usual features of StatPro. Some of you have complained that the video streaming is not smooth. I apologize for that. It may be a localized issue, but anyway, the recording will be available, so you can watch it later. I'll also check up with the platform team on this. Yeah, another very good question. Has designs been developed for circular water tanks? No. The answer is no. Right now, the first implementation that we did is only for rectangular and square water tanks. We haven't implemented the design feature for the circular water tanks yet. But circular water tanks can be modeled and analyzed in StatPro easily. I have created a YouTube video. If some of you are interested in it, I can share you my personal channel that I showed how to create a circular water tank modeling using the physical modeler. Okay, but design feature is still not developed for circular water tank. I'm following up with the development team. Definitely will be implementing it in future. Okay, but not available in the current version. Some of you requested for the copy of the stat file. Yes, I can give it to you. If you watch my presentation, you yourself can create it in less than 1 minute using the StatPro physical modeler. Okay, just fill in the blanks using the physical modeler structure wizard. Less than 1 minute, I created the model. But if you still need the file, I can send it to you. Just drop in your email address so that I can share the file with you. Okay. Another question I would like to ask, if there is a feature that allows us to account for property modifiers for walls and slabs. Property modifiers for walls and slabs. Right now, I believe you are asking for stiffness modifiers. Am I correct? Property modifiers. We do not have stiffness modifiers as a factor for walls and slab, but we have that modifiers only for beams and columns, only for members. We are not at, it's not yet available for walls and slab. But I'll request that feature based on your feedback. I'll take it up to the development team to implement it in the future versions of the program. It will be better if we can drop more details about this, why you need this feature, then it'll be easier for me to justify our development team to give priority for implementing this feature. Thank you. Another question is, ACI 350 is the current design code for liquid retaining structure in the US. Will ACI 350 be available for selection when designing concrete members? Designing concrete members. No, we don't have ACI 350 yet available in the program. But as I said, we'll be implementing the ACI code in the future version. So depending on the poll response, I'll be forwarding that poll response to the development team and request them to implement the other codes. Currently, it is not available. For the plate results, what you are shown is the contour of global moments. Do I still need to extract the plate results and manually solve for the design moment if I want to use the wooden armor method? That's a good question. Right now, the program designs the slabs and walls automatically in Rcdt, as I shown you today, as per the Eurocode 2-3. That is a specialized code for the liquid retaining structures. Wooden armor method, I don't think we have implemented that in this implementation. That is the twisting moment, converting the twisting moment into equivalent bending moments, isn't it? I don't think that we have implemented that, but if we can justify your request with some codal clauses that request that mentions about utilizing this wooden armor method, then it'll be easier for me to take it up to the development team. Right now, the Eurocode, I didn't see any clause that is referring to wooden armor method. Thank you. This video will be available in YouTube. It depends on our marketing team. I'll request them to put it in YouTube video, but by default, all the recordings of our webinars are available in our Bentley website. You can go to www.bentley.com and look for events menu on the top. And once you click on the events menu, you can see upcoming webinars as well as on-demand webinars. So use the on-demand webinars, and all the past webinars as well as this webinar will be available there on demand. Hope that answers your question. Eurocode defines 0, 1, 2, and 3 for no leak is catalog 3. So how to ensure no leak in design and how to design joints? Okay, see, the joint, typical detail about the joints is given in the detailed drawings. Other than that, we don't do any leak check. Okay. What method is used for the design of tank walls? How is in plane shear accounted for? All the requirements as mentioned in the EN0203 specialized code for liquid retaining structures, the methods as discussed there are all implemented in the program. The output file mentions about the detailed checks that we do for flexure as well as shear. Okay, maybe I can pass you on the typical report and you can go through it. How about the EDF factor? Is it considered there? I'm not sure what you mean by EDF factor. If you can elaborate that, I'll try to answer. Can the modeler and SACD for design and detailing do the same for elevated concrete tanks also? As long as the tank is rectangular in shape, it can be elevated or underground or on the ground, doesn't matter. Note that the modeler will, right now the modeler is capable of modeling for water tanks on the ground. But as I said, you can utilize to model the major portion of your modeling. And after that, once you bring the model from the wizard to the main graphical user interface of the physical modeler, and then you can elevate it, you can move it to support it by columns. Okay. So the wizard just helps you to get 80 to 90% of your modeling done easily. And the other things like underground or above ground or elevated by supporting by columns, you need to model using extra commands. Okay, those are very easy. So the answer is yes, you can use these features for modeling elevated concrete tanks also, as long as it's rectangular. Next question is, if the design requires for a site-specific linear dynamic analysis, could it also be performing using this update of StatPro? Linear dynamic analysis is already available in StatPro for many years. Okay, response spectral analysis due to seismic and also site-specific time history analysis are also available in StatPro, and that can be utilized for liquid retaining structures just like we discussed today. Since we focus today on mainly on the new features, I didn't complicate it by showing you dynamic analysis features and all. Okay, which we used to discuss in other webinars. So yes, to answer your question, yes, we can do site-specific linear dynamic analysis in StatPro in the past older versions also by specifying the site-specific time history data. So search for time history analysis using StatPro. You will get link to our community site, communities.bentley.com, and read all the topics, all the questions related to time history analysis in StatPro. That is useful for applying site-specific response spectra in any StatPro model. How about the crack width calculations? Yes, we do the crack width calculations as I shown in my presentation today. How about ACI 318? Right now, we don't have the American code. ACI 318 as well as ACI 350 for design of tank in Rcdt. Not for the wall design, water tank specific design, but ACI 318 is implemented for the other member designs such as beams, columns, pile caps, isolated footings, slabs, shear walls, etc. But we didn't implement the ACI code specifically for liquid retaining structure yet. Okay. So depending on the response to the poll, I'll be passing on to the development team. If many of you answered that to implement the ACI code, then we'll be looking into it. For underground liquid retaining, is it possible to model soil springs on walls? Yes, very easy. If you need example, you can drop your email address. I have an example, not specifically for liquid retaining structure. I have some example already ready for tunnels. Okay, the same methodology can be used for liquid retaining structures also. Modeling springs on walls is the same method like modeling springs on slabs. Slab will have a vertical spring in y direction, compression only, and the walls will have, the right side walls will have compression only springs on the x direction instead of y direction, and the left side walls will have tension only springs. The right side walls will have tension only springs, the left side wall will have compression only springs in the x direction. Okay, so I have examples for tunnels, but if you want, I can generate the underground liquid retaining structure with springs on walls also, compression only springs. Okay, drop in your email address. Thank you. Sometimes I design with a central column and beams on top slab. Yes, this, if you watch my presentation today clearly, I shown how to model the beams and columns inside the tanks. Okay, but I have not used that feature to design, but we have that feature to model the column and beams for the top slab. Okay. Okay, can share the link for the presentation. The link is the same. Same link you used today to join. You can use the same link to watch the on-demand presentation after 2-3 hours from now. Okay, and also it will be available in our website bentley.com. Look for events, on-demand webinars, and use the title for today to search the webinar. Can we import BIM model in physical model? Yes, the answer is yes. If you watch some of my previous webinars, I did demonstrate that to import a BIM model from Open Building Designer into StatPro Physical Modeler. I also have my personal channel, a YouTube video. I can share you the link later. Just drop in your email address. The process is simple. If you use a BIM software like Open Building Designer or Revit, all you need to do is export the file in ISM format, ism.dgn format. If you use Open Building Designer, you can see there is an option, analysis option on the top, and there is an ISM feature there, and you can use create ISM file. If you use Revit, you just need to do a Google search and search for ISM plugin for Revit. ISM stands for Integrated Structural Model. ISM plugin for Revit. It's a free download available from our website. Download it and install it on your computer, which has Revit. And then once you open Revit, you can see a Bentley menu there. And in the Bentley menu, you can see the ISM export, import, all those options. And you can see several YouTube videos on the BIM interoperability with StatPro. Just search BIM interoperability with StatPro. You can see several YouTube videos, including my own video. If you find difficulty, just drop in your email address. I can share you the links. Thank you. Can the modeling of dynamic fluid loads be included in the software? Dynamic fluid loads are not included in the software yet. Right now, we consider the fluid loads as static. But if you want to model dynamic fluid loads, you have to model it using the time history analysis feature in StatPro. But those are not automated yet. So you need to come up with a time varying force function to be input as time versus force using the time versus time history analysis in StatPro. So dynamic fluid loads can be modeled in StatPro with certain difficulty as long as you have the time versus forcing function. But it is not an automated simplified feature in StatPro. Okay. Can you design the walls with earthquake? Yes, the earthquake loading, the walls can be designed for any loads as long as you specify the earthquake load using static method or response spectra or time history. Then the program will be able to analyze for it and come up with the wall moments and forces, and then the program will be able to design for it also. Okay. So earthquake is just a load that you can easily apply in StatPro. How about ACA 350 design with hydrodynamic loads? Hydrodynamic loads right now, you can model it as static loads only, not as a dynamic load, as I discussed before. But if you want to apply as an impulsive dynamic load, you need to have that graph, time versus force graph. Then you can use the time history analysis in StatPro to simulate that. But ACA 350, we don't have it yet. I'll take it up to the development team to implement in the future version. But right now, we support only the Euro codes for the water tank design. Do you provide material learning about training today? This is a very short feature. If you want, I can give you the PDF file. Just drop in your email address. I can share the PDF file. But it's a simple thing. One structure wizard in the physical modeler to create the model, and then the tank design feature in the Rcdt. Very easy to learn. I would suggest you to watch this recording later, and also there may be some other YouTube videos also available for you to learn. And very soon we'll be putting up a training documentation in our LAN server, lan.bentley.com. Another question, can we add external wall load such as earth load in physical modeling? Yes. If for example, if it is an underground tank, then you need to model the earth load, isn't it? Lateral earth load. Yes, very easily. In the physical modeler itself, you can model the earth load. I would suggest you to watch my previous presentation. I believe it is my last year's presentation on physical modeler and another webinar on applying load groups, where I have demonstrated how to apply lateral loads in the physical modeler itself. It's very easy. All you need to do is just invest your time, at least 2 to 4 hours of your time in learning the physical modeler properly. There is separate trainings available, on-demand trainings, as well as live trainings, instructor-led live trainings that are happening quarterly, every quarter in this Asian time zone. So please log in and look for those trainings in learn.bentley.com, LEARN, learn.bentley.com. You can see trainings for physical modeler of StatPro. Okay, so once you invest that time, you learn easily how to apply lateral earth pressure, how to apply wind load, how to apply seismic load using the physical modeler itself. Next question, does this apply to silos? Silos are usually, my experience of designing silos, I utilize the analytical modeler of StatPro. There is a wizard, just like the physical modeler wizard, we have a structure wizard in the analytical modeler, and there is a macro available specifically for silos. I would suggest to utilize that macro to model the silo, because the bottom of the silo will be a conical shape with an opening, isn't it? So you'll use the silo for storing some material, okay? And the silo is usually have openings with some conical projection at the bottom, isn't it? So I would suggest to utilize the analytical modeler structure wizard, and you can see macro available there specifically for silos. And those silos using that macro, you can even model the columns, beams, along with the plates. Very easy. So if you need more information, if you find difficult to find that one, drop me your email address. I can help you to use that feature by giving you some screen captures and with example model also. Thank you. Can a circular water tank be included in the next version? That is one of my requests. I've been following up with my development team. I can't promise for next version. It will be definitely included in the subsequent versions, but I can't commit any date for now. Okay, thank you. Tank shape is limited to square. How about circle? Yeah, the same thing. Yeah, we'll be working on, we'll be implementing the circle very soon, but may not be immediately in the next version, but definitely in the future version, circular water tanks, designed for circular water tanks also will be available. But note that modeling and analysis, anytime you can do it in StatPro, even now. It's just a design feature which is lacking for circular. Can we model odd-shaped tank using physical modeling? Yes, odd-shaped tank, like a combination of rectangular, circular, yeah, any shape, any irregular odd-shaped column can be, odd-shaped tank can be modeled in physical modeler. Very easy. Physical modeler compared to the analytical modeler is a better way of modeling. You can even use BIM softwares like Open Building Designer or Revit to model it and import it in a physical modeler. Or you can directly model it in physical modeler itself. So there are separate trainings available for the physical modeler. Please utilize it to learn the physical modeler. It has powerful feature to model any complex shapes. I would suggest you to watch my last year webinar on physical modeler, 1 hour webinar purely focusing on the physical modeler. It's all available in our Bentley website. Another question, the input for fluid density is only for one fluid type only. How about for multiple fluid type or compartment present in the tank? Fantastic question. We never thought of it. We never thought of it. Yes, I'll bring this feedback to our development team to have multiple fluid types in multiple compartments. But it is not a difficult task for the user. Right now, you can still use the current facility and just modify the load, generator load, or for the other fluid type, you just need to calculate those lateral pressure and vertical pressure manually. That's it. But I'll definitely give the feedback to the development team to put in multiple fluid type density, multiple fluid density in different compartments. Thank you for session. Can you also apply the parameters for seismic load of liquid retaining structures? Yes, we have the seismic load option in StatPro, which you can use it for any structure, not just liquid retaining structures, as per any seismic code. Does the concrete designer also facilitate design and detailing of complex shapes of tank walls? Circular with openings, etc. No, we don't support circular walls now, and openings also we don't support. Small openings, the detailed drawings will take care of it, but big openings we don't support it right now. We'll be considering those features in the future versions of the program. Okay, I see many email addresses for sharing the PDF, sharing the model. Okay, another question is the tank is installed underground. Is the horizontal soil pressure outside the tank is also automatically calculated? No, it is not automatically calculated. You need to manually calculate it, and it's easy to calculate and it's easy to apply also. All you need to do is use the hydrostatic trapezoidal load feature in StatPro. Select the surface of the wall and specify the maximum load on the top and minimum load on the top and maximum load on the bottom, and the program will automatically interpolate and create the hydrostatic trapezoidal load. So it is not automatically calculated now. You need to calculate it manually, but the application of that is automated. Okay. but we haven't come up with a wizard for that yet. But applying that manually is not a big task. Very easy. Just remember the hydrostatic trapezoidal load option. Okay. Many email address. Can seismic loads for water tanks be auto-generated impulsive? Seismic load. I believe I answered this already. Seismic loads for water tank. The seismic loads can be calculated uh, in the program. If you are referring to time history loads or response spectral loads, both the seismic loads can be generated in StatPro, but they are not specifically available for water tanks. They are available for the usual building type of structures. But if there is separate seismic codes that are specific for water tanks, then we may not have it. Okay, so please enlighten me on that. If there is any seismic code specifically for water tank, we may not have it in StatPro. Okay, but if the same seismic loads that are that is used for the building code can also be used for water tanks, then we have it already. But if there are separate seismic codes that are specific for water tank type of structures, then we can use the generic features, the user-defined features of StatPro for response spectra as well as time history analysis to create an impulsive seismic load. Can we model the structures in BIM such as Revit and Import? Yes, I already answered this. Very easily, you can model it in Revit and use the ISM plugin feature. Search for Google search ISM for Revit, ISM plugin for Revit. Download it and install it on your Revit computer and use that feature to export to StatPro Physical Modeler. I also have a YouTube video for that. Drop in your email address. I can share you the YouTube link. Is it possible to model underground tanks with compartments of different depths? Compartments of different depths. Underground tanks, yes, you can model it very easily. Just the difference is only that you need to manually model the lateral earth pressure and the lateral support springs, compression springs. But compartments of different depths, you need to modify after using the structure wizard. You need to modify that in the physical modeler, or you totally can create the model in the physical modeler without using the structure wizard also. So various methods. You can also bring it from a BIM software. Various methods to do that. How does the design and detailing work for elevated concrete tank? Will the wall be designed and detailed as a deep beam? The wall designed as a deep beam. The wall design right now we are referring to the EN0203 code. I don't think it designs that as a deep beam. Anyway, I'll double check on that. But elevated concrete tank can be modeled using the same wizard. You just need to fine tune it. Just get the 80% done in the structure wizard and then add the column and move the tank. So just few modifications need to be done. Then you can create the elevated concrete tank. As long as it's rectangular, it is easy. Deep beam design, I'll check up with the development team on that. Meanwhile, if you can support us with some clauses in the code, that'll be easier for us to help you on that query. Wall penetration, any design consideration? I'm not sure what you mean by wall penetration. Are you referring to some cutout or opening? If it is small opening, then we give the cutout, standard cutout detailed drawings. That should be good enough. But if you're referring to something else, please be more clear on that wall penetration. EDF means environmental durability factors. Okay, I'll come back to you on that. Right now, I am not familiar with that term, environmental durability factors. I'll check on that and I'll come back to you. Please drop in your email address so that I can reply to you through email. Thank you. Did the EN code consider the hydrodynamic analysis? Hydrodynamic analysis. This is right now, it is a static analysis only. The loads that are generated due to the water load inside the tank are considered as static loads only. Okay. So it is not a hydrodynamic analysis. It's a hydrostatic load, I would say. Will be interested in the model of underground liquid retaining structures. Okay, the email address you are given. So I'll try to give an example. I'll also try to capture a video and send you. Underground liquid retaining structure, please. Okay, so few of you are requested for underground retaining structures example. I'll send it to you. Okay, some of you are requested for a structure with lateral soil springs. So I'll send you the tunnel model which you already have. You extend that for liquid retaining structure. The same concept. Can we export reinforcement detail from Rcdt to pro structure? See, the reinforcement details of Rcdt is basically a 2D detail, which you can save it as DXF file and you can open it in pro structures. The pro structure is basically a 3D modeling software, reinforcement modeling software, as well as steel detailing software. So I suggest, I think what your question may be is to import it in 3D reinforcement. If that is what your expectation, the answer is no. The reinforcement detail from Rcdt is basically a 2D detail. If you want to open it in pro structures using the plain microstation or AutoCAD feature, yes, you can do that, but not in 3D. There are developed plan for design tank with ACI. Yes, definitely we have plans, but not in the immediate next version, but definitely in the future version we'll be implementing the ACI code for the water tank design. Okay. Some of you mentioned thanks, the content was valuable, many email addresses. Could you also send them all to me? Yes, definitely. As long as you have the email address, I'll go through it one by one. I'll send you the models. Okay, so with that, we come to the end of the last question. Okay, so thank you very much for all of you to attend this presentation, and mark your calendar for every Thursday every third Thursday of the month to join our coffee corner session like this. These sessions are addressed towards the users to make our users power users, okay, to make a basic user advanced user by introducing them the latest features, the greatest features, the advanced features, okay, and to make you as the advanced user. That is the purpose of this kind of coffee corner sessions. So thank you again for joining and participating in the polls. We'll meet you again next month. Thank you. Bye.